regions rather than others, such as Rangoon within the Irrawaddy, and differences there, sometimes such as the Nile Delta, a universal spread of high-density farming and small cited people. But one characteristic, they all tend to be dwelling in low-lying and consequently exposed areas. But more importantly, and I take here this illustration from Bangladesh, if you look at the top right-hand side there, most of our delta areas, particularly in southern and eastern areas, not only expect substantial population rises as other parts of the world, but more than the global average, substantially more, for a number of reasons, because they have long been attractive and will remain so. And you see from the top right-hand side there, even for a range of SRES scenarios, we expect the population of Bangladesh perhaps to double by the middle of this century. That's much more than the global average. In addition to that, may I add my fourth climate change point, that we have great uncertainty about how income levels will develop in these areas. They could grow, the regions could prosper, or they could continue at their current or least recent historic rate, such as shown in the A2 scenario you see in the lower slide there for Bangladesh. There is the prospect then of Dhaka and Chittagong and places like that becoming the Singapores of the future, as shown here in the B1 and B2 scenarios with high levels of income, or they may continue at present. More likely they'll be somewhere in between. But making assumptions about that is, which hold ground and are robust, is hugely important in saying something about the best, the optimal adaptations in the future. Consider this diagram, which I consider to be one of the most useful in the IPCC from Robert Nichols. When you make assumptions about income, and you also assume that you invest pro rata according to income to defend yourself against sea level rise, which is what he's doing here, and you map, in this case, global risk from flooding, you get huge differences according to whether you are dealing with a future wealthy population or a future population that's simply an extrapolation of the present, with high income inequalities, with large megacities, with substantial poor and marginalized people who will tend to be most at risk. Which is why in A2 there, what he is essentially saying is the risk from poverty in megacities is greater than the risk of sea level rise, the light green as against to the purple green. But when you start to add sea level rise, you have a compounding effect. And even with our optimistic projections, where we might begin to grow ourselves out of risk of flooding, do you see in A1 there, from 220 to 2050s, or B1 from 2050s to 2020s, it looks as if we're developing ourselves out of the problem until sea level rise becomes an issue. And then the numbers increase again. And that enabled then Robert Nichols and others to put a similar set of numbers with uncertainty bars against the array of projected sea level rises. And I'm using that because in a minute, before I close, I just want to put these numbers together. Well, I haven't said anything about adaptation, but most of you will be occupied with that this week. What I just want to say is they range clearly from high-tech, expensive, sophisticated, probably in this case, and I know this is not from a Delta, untested efforts, to highly tested, simple, inexpensive, and highly effective. What we don't have, it seems to my mind, is an obvious relation between the two. We know that Hurricane Ike, for example, had relatively small impacts in Cuba, no deaths, whereas Hurricane Katrina had substantial numbers, which is something perhaps about the brittleness of adaptation, even if it apparently is substantial. Finally, let me put these numbers together from two strips I've shown you of water and coasts. And rather than rely upon the suite of impacts that are showed there by the IPCC, and pointing you to the right-hand line, which is some central measure of impact if we do nothing, it's actually surrounded by an uncertainty range of about 0.5 degree either side there. make the point that if we do nothing, all those impacts on the left, we will have to adapt to or otherwise bear them. But we know that Copenhagen did make some initial pledges, and if those pledges are fully implemented, not only financed but fully implemented, the UNFCCC's estimation is that temperatures might peak at something like 2 to 2.5 degrees. On the other side of the coin, we know that the UNFCCC at Copenhagen pledged, and it was mentioned this morning, a sum of $65 to $80 billion a year annually by the 2030s. Now that may actually pick up only varied amount of damage in different sectors. I don't have the time to argue those, but I simply want to make this point, that when you put these two together, you are left with a big gap. And we need to think of deltas as falling into this category as much as any of those most vulnerable sectors identified by the IPCC. And one question is, how do we avoid that big gap between what we can adapt to, what we can mitigate against, and something in between? So, we already have high vulnerability in these delta areas, high flood risk, weather extremes, a large exposed population, but we have especially further increasing, indeed faster than average increasing vulnerability, decreased accretion, subsidence, a faster than normal growing population, and climate change has added a suite of these, not only sea level rise, but intensified weather extremes, possibly altered regional runoff, impacts on ecosystems, food supply, water availability. And this leads to me to add a few more challenges, if I may, to those that Oppenheimer put before you, which are these. The delta is arguably a special nexus of multiple certain stresses, certainly multiple, probably mainly compounding rather than buffering. What is our challenge? To think of those in combination or in isolation? Or in isolation first and then see how they combine? That seems to me to be an analytical question. Secondly, deltas are parts of regions and countries, obviously. So how do we integrate spatial planning for these into the national context? Well, the Dutch of you here are experts on that. And finally, while recognizing that deltas have special needs, we need to think of this special need as being resourced in competition with other special needs, because they are indeed out there, and the IPCC highlighted them. In other words, where do deltas stand in the competition for adaptation financing in the global context? Thanks very much.
Thank you very much, Martin. Uncertainty on a massive scale, the real importance of mitigation as well as adaptation, and the scale of the people at risk is really what came out of that for me. We'll press on with our next speaker, Professor Pavel Kabat, who is head of the Earth System Science and Climate Change Research Group at Wageningen University and Research Centre here in the Netherlands. And he is Science Director and Council Chair of the Dutch National Research Programme on Climate Change's Spatial Planning. He leads he's one of the lead authors of IPCC and is also a Nobel Peace Prize winner in 2007. Professor Kabat is going to speak on climate proofing in the Netherlands, climate change and spatial planning and their interaction. If I can invite him to the stage.
Ladies and gentlemen, I'm standing here today not as Pavel Kabat. I'm standing here on behalf of many of you in the room, because that little print, the website, www.climateresearchnetherlands.nl, this is where I'm coming from today. I'm standing here on behalf of two large research programs. One is called Knowledge for Climate, which is this nice little logo in the upper right corner. The other one is called Climate Change Spatial Planning, which is a program we developed together with many of you. So today I will tell you something about how research developed in these two programs and how much that research actually was used and applied in the daily practice